this video. Today we are going to talk about a very interesting topic called distance between two nodes in a generic tree. Now you must be wondering where we get these questions from, right? So I'd like to ask you to visit our website, pepcoding.com, where you can find many resources related to placements and other interests. Here you can find any resource regarding your interest. So out here in data structures and algorithms in Java, you can find many questions and problems which will help you crack your interviews. So what are you waiting for? Go ahead and solve these problems. Now let us discuss how we are going to approach this problem. So let us consider we have a tree like 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110 and 120. So we've got this tree, and in this tree what we have to do is we have to find the distance between 110 and let's say 40. So the distance between 110 and 40 will be the number of edges between these two nodes. So let us count the number of edges which are present between these two nodes. So for one, let's start from here, 110. Here we are going to start. So one edge, so 1. Then we get here, which is going to be 2, then 3, then 4. So the distance between 110 and 40 is going to be 4, right? 1, 2, 3, and 4. Now, what if we have to find the distance between, let's say, 50 and 70? So let us see what the distance is going to look like. So for 50, we'll start by counting this edge, 1, then this, 2, then it was here 3, then 4. So the distance between 50 and 70 is going to be 1, 2, 3, and 4. So let me write it. 50 and 70 is going to be 4. So now that you have got an idea about how to find the distance between two nodes in a generic tree, let us discuss the approach that we are going to take to solve this problem. So first, let me just delete this tree. Let us start with a fresh and new tree. So that tree is going to look the same. 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, and 120. So if you have to find the distance between, let's say, 110 and 70, the first thing that we are going to do is we'll just write down the node to root path between node to root path for both 70 and 110. So for 70, the node to root path is going to look like 70, then 30, then 10. So this is the node to root path for 70. So it is starting from 70, then it is going to 30, then it's going to 10. Now for 110, node to root path for 110 is going to look like this. Let's start from 110, then go to 80, then 30, then finally 10. So here we have the node to root path for 110. It's 110, then 80, then 30, then 10. So let me just give these indices like 0, 1, 2, 0, 1, 2, 3. So now we've got the node to root paths for both the nodes. Now what we're going to do is we'll check for the lowest common ancestor. Now for those who don't know what lowest common node is, I'd urge you to go and watch a video in YouTube. So moving ahead, what we are going to do is we'll first check what is the lowest common node for these two nodes, which is going to be 70 and 110. So let us see from node to root path and see what node is closest and both common to the two nodes. So if we go from 70, we'll find that 30 is here and then 10 is here. Then if we go from 110, we find that 80 is here, but it is not connected to 70. So it can't be an ancestor. So after that, we go to 30. And you can see that both the nodes are connected at 30, and it is the lowest and the more common ancestor for it. So what we are going to do out here in this problem is that we'll check from here, from the back. We'll check for equality of the two nodes. We'll check whether the two data in the two nodes are equal or not. If they are equal, we move on to the next. We'll decrease the value of the index. We'll move on to the next. So for the first nodes out here, we check whether 10 and 10 is equal or not. Then we go, they are equal. So we go to 30 and 30. So 30 and 30 are equal. After 30 and 30, we go to here, 70 and 80. We see that 70 and 80 are not equal. So we terminate our condition. After terminating the condition, we have got the index number I for this path as 0 and j for this path as 1. So these two indices are pointing to the first uncommon node, and we know that the common node between these two paths is out here, right? So what we'll do is we'll add a value I plus plus. We'll just add 1 to this value. So now what we are going to have is 1 and j will become 2. So 1 and 2. So now if you see that when we add the value of I and j, which is actually pointing to the lowest common ancestor, then we can find the distance between the two nodes in a generic tree. So if we add 1 plus 2, then we'll get 3. So let us see whether it's true for this node or not. So out here, we have 70. So let's start from 70. So we are starting from 70. We'll move on to 30. Then we found the lowest common ancestor. So what we do is from here we come here, which is going to be the other node. Then we come here. So between these two nodes, we can see that there is 1 edge, 2 edge, and 3 edge. So the total number of the total distance between these two nodes is going to be 3. And from that LCA, from the indices of the LCA2, we found that the distance between the two nodes is going to be 3. So this is the approach that we are going to take in this solution. So let us go and code the solution. Now let's code the solution for this problem. So here we have been given the question and the function is here. We have to write the function out here. So let me increase the size of the editor and let's delete this. So the first thing that we are going to do out here is we are going to find the node to root path for both the nodes. So we are going to save that in an array list. So we'll create an array list and we'll give it a name path1. So this array list is going to store the node to root path for node 1. So let us give it here root path for node, which is going to be same for both the nodes, and d1. This is the data for the first node. So we are going to create another array list. And this array list out here, it is going to store the path for the second node. So node to root path. And we'll give node and the second data, which is going to be d2. So now that we have found the node to root path for both the nodes, what we are going to do is we are going to traverse through the two array lists and find a point where the nodes are uncommon, or where the nodes are unequal to each other. So in order to do that, let us take two indices, which is going to be in I and int j. Okay. So we're going to take these two values, I and j. I will point to the path 1 and j is going to point for path 2. So what we are going to do is we'll initialize ith value with the last index of the path 1. So it is going to have the value path1 dot size minus 1, because this is the last index of path 1. Now for j, we'll give it the value of last index of path 2. So minus 1. So now we have initialized them. Oh, sorry, declared them. So what you're going to do is we'll traverse through the arrays. So while I is greater than equal to 0 and j is greater than equal to 0, and while traveling, we are going to check whether the value at ith position and the jth position are equal or not. And the loop is going to terminate if the value of ith and jth position are unequal. So let us write the code for that. Path1 dot get I is equal to path2 dot get j. So while I is greater than equal to 0, j is greater than equal to 0, and the path1 dot get I, which is the ith value of in path 1, and the jth value in path 2 are equal, while these two nodes are equal, what I'll do is I'll traverse through the array by decreasing the value of the indices. So I minus minus and j minus minus. So this loop will terminate when it finds the first uncommon element, nodes between the two nodes. Okay. So once it finds that, after coming out, we'll just increment its value by 1. Both the values by 1, because we know that the value next to the first uncommon nodes is going to be the lowest common ancestor. Okay. So now this I++ and j++ out here, it's going to point to the lowest common ancestor for these two nodes. After that, what we'll do is we'll calculate the distance. In distance, and what you're going to do is we are going to add these two values, I and j, and after adding, the only thing that is left for us to do is we have to return this value distance. So we have done with the code. Let us see whether it runs or not. And our code has been accepted. It means that our answer is correct. So let us see if it works for all the test cases or not. And it has worked for all the test cases and it has been accepted by the compiler. So let us discuss about the time and space complexity of this code. Now let's talk about the time and space complexity of this program. Since we are traversing through the tree to find the node to root path, the time complexity of this program is going to be bigger of n. And the space complexity is also going to be bigger of n because we are going to store the node to root path in array lists. Now with this, I'd like to end this video. I hope you understood how to find the distance between two nodes in a generic tree, and please like and subscribe this channel.